Okay, so today we'll be starting with pages and page replacement algorithm. So what is paging and why are page replacement algorithms required in the first place? So let me tell you, our our RAM in the system or the random access memory, or also known as the primary memory, is limited. We have to load the processes, that is the CPU have to load the processes which may be bigger than the RAM. So how does the CPU actually do that? The processes which might be bigger than the RAM are actually broken down into pieces or chunks or individual tasks that are called pages, and these pages are then loaded as needed into the primary memory or the RAM, which has page frames that are physical divisions in which the pages will be loaded. So since the memory might get full, CPU has to do the page replacement. Why? Because it cannot hold all of the pages of a current process. It can hold some of them, but then it might request a page from some other process or some other page from the same process. So what does the CPU do? Which page will it replace to get the new page? That's where page replacement algorithms come into the picture. They decide, or they help the CPU decide which page to replace. So in this video, we'll be going over three page replacement algorithms. First is first in, first out. Second is least recently used, and third is optimal page replacement. So let us quickly go over the basic theory, and then we'll move on to the code. Let us say we have four page frames: page frame number 1, page frame number 2, page frame number 3, and page frame number 4. And all of them are filled one by one. For example, first page frame is filled with 5, then second with 6, then 1, and then 2. Now, what if the CPU needs page number 7? It checks the page frames, and since the page frames do not contain, it is called a page fault. Page fault. So what does it do? It searches the secondary memory for the requested page, and then this page is loaded into the frames. Now what does FIFO tell is the first page that came into the page frames must be the one that will be removed. That is why first in, first out. So first page that we filled was 5, and according to FIFO, we have to remove 5 and 7 will be placed over here. Now, what if the CPU requires page number 4? Again, it will check the page frames. Since they do not contain, we have to replace one of the pages and put 4 in its place. Which one will be replaced? So now, since first element was this one before the 5, and now the first element that was placed before all of the others is now the frame number second, has the second element, that is 6. Now it was the first element, hence it will be removed and 4 will be placed in its place. This is the basic idea of FIFO. So now let's move on to its code. Every program in many of the programming languages starts executing from the main function. So what does the main function is doing? It's basically initializing a scanner to take input from the user, and then it's calling a menu function and passing the scanner as an argument. So we go to the menu function. What is the menu function doing? It's actually taking input from the user. It's very basic. What we'll be doing is taking number of pages, then we will be taking and making an array which has the size of number of pages. Then we will be taking a reference string. So what is a reference string? It is nothing but a sequence like 2, 0, 4, 8, 6, 9, which are the pages requested by the CPU. So this reference string tells us that these pages might be requested by the CPU, and we store it as integers. So how do we do that? We convert from string array to integer array by using the integer.parseInt on each element. After that, we'll take the number of pages and we'll store it as the capacity of a frames queue. Now, since we saw the basic idea of FIFO is nothing but first in, first out. So which data structure is best to implement first in, first out? It's nothing but a queue. So what is a queue? Queue is nothing but a data structure, or it actually performs like a physical queue. So for example, in a movie ticket booking place, you will be finding yourself standing in a queue, a line. The first guy who was before you will be the first one who will be executing the queue. That is nothing but FIFO. So we will be using the queue in a code. After the menu function, the menu will present the user with a menu where he or she will select one of the page replacement algorithms. So for the first case, it's first in, first out. So let's jump to its definition and see what it is doing. First, pages equal to pages.clone is nothing but cloning the pages array, since we might tamper with it. Then we'll be initializing a queue data structure, that is frames queue, with linked list as its backbone, that is it's interfacing a linked list, implementing a linked list. Then we will be initializing two variables, that is page faults and page hits. Page faults is nothing but if a page is requested by the CPU but it is not present in memory, that is the page frames queue, then it's page fault. So what is page hits? Page hits nothing but if a page is requested by the CPU and it is actually present in the frames queue. So now let's move on to the main logic. So what are we basically doing in a page replacement algorithm? If first we check if the frames queue is full or not. So yeah, if the frames queue is not full, that is it hasn't reached its capacity, that is checked by this condition. Then we check if the current page that we are processing, it is already present in the queue or not. And for that, we are using the contains function that returns true if the pages of I is present in the frames queue. And then we will invert it using a not. And if it is not present, then we add it to the frames queue and then increment page faults counter. Since it is a page fault, it wasn't present in the frames queue. Then this for loop is used just to iterate through each element in the frames queue and print it out to the console. Else, if the frames queue contains returns false and then we invert it to, if it returns true and we invert it to false, then we go to the else part. That just means that it already is present in the frames queue. So we increment the page hits counter. And if the frames queue has reached its capacity, then we have to perform page replacement and we'll use the FIFO page replacement algorithm. And since we are using frames queue as a queue data structure, we just have to remove the first element which was added to the queue, and that is done using this function. It is done using this function, poll function. Once we have removed the head, that is the first element of the queue, then we add the page whichever you want to add. It will be added at the end of the queue, obviously. Then we increment the page faults, print out the elements, and if the page is already present in the frames queue and the frames queue is full as well, then still we just have to increment the page hits counter, and that's it. That's the first in, first out page replacement algorithm.